So we're going to go over gram, mole, and atom conversions on this. And before we really get into it, it's important to recognize that gram is a unit of mass. We use that for determining amount of things. The mole is a counting number. Okay, so it's actually an amount. And then atom is a thing. Okay, so generally speaking, things we know are made of atoms. We can count how many atoms there are, and that will have something to do with its mass. And so all these are interchangeable. 1 mole of any object contains 6.022 times 10 to the 23rd of whatever thing that is. And so if that were to be clowns or pennies or whatever, that's how many objects would be in 1 mole of that object, the same way that there are 12 of something in a dozen. A mole of any atom contains that many atoms, 6.02 times 10 to the 23rd atoms. Okay, huge number of atoms. So 1 mole of carbon atoms is 6.022 times 10 to the 23rd carbon atoms, and it just so happens that the mass of that many carbon atoms is equivalent to the atomic mass of that as we see it on the periodic table. So if you had that many atoms of carbon, it would weigh 12.01 grams. And this is one of the things that allows us to get at a mass by counting, or to count a number of things depending on what they weigh. So it allows for us to do conversions. So 2.5 moles of aluminum, how many atoms is that? Well, I've got 2.50 moles of aluminum, and every 1 mole of aluminum contains this many atoms. Right? So moles of aluminum cancel. I've got this many atoms left, and that leaves me with 1.51 times 10 to the 24 atoms. This is larger than Avogadro's number, and that should make sense because I've got more than 1 mole here. And that's a check you always want to do. Does this make sense? 3.5 grams of sodium. How many atoms is that? All right, well, 3.5 grams of sodium. There's no real direct connection between grams and atoms without going through the mole. So a mole of sodium would have a mass of 22.98 grams. That's per the periodic table. And every mole of sodium contains 6.022 times 10 to the 23rd atoms. So moles cancel, as do grams. And when I multiply this by this, divide by that, I end up coming to a number of 9.17 times 10 to the 22 atoms. Okay, this is a huge number, but it is smaller than Avogadro's number, and that makes sense because the number of grams I have is less than 1 mole of sodium, which would weigh 22 grams. I only have 3.5, so that means the number I get back should be less than Avogadro's number. Now, we can make these a little more complicated. This isn't too much more complicated, but this is a common thing you might see. 70 atoms of cobalt, what does that weigh in grams? Well, not much. So 70 atoms. And I'm going to keep this to 2 significant figures of cobalt, not carbon monoxide, cobalt. Well, I want to change that to moles. And that's how many atoms are in a mole. And every mole of cobalt, if I have that many atoms especially, would have a mass of 58.93 grams. And when I go through and do this math, I should get a very small number, 6.85 times 10 to the minus 21 grams. So like I said, 70 atoms of cobalt would not weigh all that much. Now, because I can go between mass, moles, and atoms, the mass can be in any units. It could be in pounds, it could be in kilograms. In this sense, I'm given micrograms. Because I know metric to metric conversions, these conversions are not that bad. So 4.5 micrograms of lithium, a mole of lithium, well, I'm getting a little ahead of myself, aren't I? Let's start this again. 4.5 micrograms of lithium, a microgram and a gram have a relationship. 1 microgram is 10 to the minus 6 grams. And every mole of lithium has a mass of 6.94 grams. and every mole of lithium has 6.022 times 10 to the 23rd atoms. Okay, so at this point I can get moles from this and I can get atoms from this. When I go all the way to atoms, this would equal 3.90 times 10 to the 17 atoms. And that number makes sense because 4.5 micrograms is much less than 6.94 grams. And 4.5 divided by 6.94, that would get me to 6.48 times 10 to the minus 7 moles. Okay, so we are in good shape. We can convert between masses, moles, and atoms, and we should be able to go backwards and forwards in this conversion. So I hope that helps.